Okay, good evening everybody. Today we're going to be talking about estimating square roots and rational and irrational numbers. You're going to need to put a lot of green because I don't have much room to write this stuff down, so I'm going to say it. Green, a lot of fifth color, so please add plenty of fifth color to your notes because you have more room to write than I do. Okay, so we're going to take a look at rational and irrational numbers to begin with. And so there's two major groups, rational and irrational. And we're going to talk about rationals first. Rational numbers are pretty much any number that you come across. It's the numbers that we're used to seeing. And inside of rational numbers, there are two subsets. There's integers and there's natural numbers. So we're going to talk about what natural numbers are first. So natural numbers are the counting numbers that are positive. So like 1, 2, 3, no decimals, no fractions, on and on and on. Okay, those are called natural numbers. Now, integers are very similar to natural numbers, except that they include negatives. So -3, 5, -9, -2. Again, any positive or negative whole number is an integer. Again, no decimals. So the difference between rationals and those two is that we now include decimals and fractions. So like 5, 4.7, -2.6, 0.312. Any number that can be written as a terminating or repeating decimal. Basically, and here's the fifth color, a number is rational if we can write it as a fraction. So if we can write it as a fraction, it's rational. So I should probably put at least one fraction on here. So like 3/5 is 1. Okay, so any number that we can write as a fraction is a rational. If we cannot write it as a fraction because it never repeats and it never terminates, then it's an irrational number. So irrational, that leads right into irrational numbers. The most famous irrational number, of course, is pi. Just about everybody knows that pi never repeats and never terminates, goes on for millions of decimal places and never repeats and never terminates. But the other way to remember it, or to remember these are square roots that we don't have memorized. So like the square root of 7, or the negative square root of 13. So if it's not a square root that we have memorized, it's an irrational number. If we can memorize it, then it's a rational number. So make sure you add those fifth colors to your notes of the difference between rational numbers, which are numbers that can be written as fractions and are terminating or repeating decimals, or irrational numbers are numbers like pi or square roots that we don't have memorized yet. Okay, so that's the difference between rational and irrational. So most of the numbers we come across are rational, just to let you know. All right, let's take a look at the next slide. So here we're going to do some estimating. This is what I want you guys to get very, very good at, is estimating these square roots. I don't want you to grab a calculator and take the square root of 27, so it's going to give you a super long number. So what I want you to do instead is to start by doing this by writing it on paper, but then eventually do it by not writing it on paper. So what I want you to do for this is think about the two perfect squares that are close to 27. So if I think about the number 27, I have a perfect square that is below it, which is 25. And the square root of 25, of course, is 5. And then I have a square root that's above it, which is 36. And the square root of 36 is 6. So then what you do is you take a look at this number right here, and you said, okay, is 27 closer to 25 or 36? Well, of course, it's closer to 25, which means the square root of 27 is going to be pretty close to 5. So what we would say then is the square root of 27 is about 5 point, because it's going to be a little bit bigger than 5.2 would be a good estimate. So 5.2. What would not be a good estimate is 5.9, because 5.9 would be very close to 6. So 5.1, 5.2, maybe 5.3, although even 5.3 is getting kind of big. But I probably would take 5.3. So you see that 27 is pretty close to 25, therefore it needs to be closer to 5, which means it's going to be 5.2. Okay, now take a look at the next one. So I'm looking for two perfect squares. One's going to be bigger than 48, one's going to be smaller than 48. So I'm going to write the negative square root of 48. So I'm going to go ahead and write it in here, and I have square root of 49, so that would be the negative square root of 49. Notice that I put this to the left of it, even though it's bigger, because of the negative. Remember, if we're thinking about a number line, the larger numbers go to the left, the smaller numbers go to the right when you're talking about negatives. Okay, so negative the square root of 49. And then the one smaller than that, so this of course is then, excuse me, I got to erase that because I want that to be in green. So negative square root of 49. And then so this would be the square root of negative square root of 49 would be negative 7. So then the one on the other side, of course, is going to be negative 6. Which would be the negative square root of 36 again. So now I'm looking at these and I go, okay, which one is it closer to? Well, it's closer to 49, but it's not quite 49. So that means we can't say 7 point. This is what a lot of people want to do, is they see that this number right here is super close to this one, therefore it must be 7 point something. It's not 7 because we haven't got up to 49 yet. So this one is going to be negative 6, because I'm bigger than 36, but haven't got up to 49, so that means I'm somewhere between this number and this number, so that means it's going to be about negative 6 point, and it's super close to 49, so I would say 6.9. So this would be my answer right here, negative 6.9. And again, I probably would take 6.8, but I don't know if I would take 6.7. Okay, take a look at the next one here, 52, okay, square root of 52. So I'm going to go ahead and write that in the middle like I have before, and I'm looking for the number that is just smaller than it, which would be to the left, and then there's a little bit bigger than it, which would be to the right. So the perfect square, you can see why you want to memorize those perfect squares. It goes a lot much quicker. The square root of 49 again is the one that's just smaller than it. And the one that's a little bit bigger than it is, so this would be, let me jump back here, this would be 7. So that means that this one has to be 8. And so then that means it's the square root of 64. And you see how I do that is I got one of my perfect squares, I took the square root of it, and then I know the other one has to be one bigger. So if this is 7, this one has to be 8. If this one was 5, this one had to be 6. If this one is negative 7, that one has to be negative 6, because this is the bigger one over here, because it's less negatives than this is. Okay, so then I look and see, okay, this is kind of in the middle-ish, you know, it's a little bit closer to 49 perhaps than it is 64, but it's a little bit in the middle. So then this is going to be then about 7 point, and then 4. Would be probably pretty good. 7.4. I might take 7.3, would be okay as well. And that's estimating. That's what I want you guys to do for estimating these irrational numbers, these non-perfect squares. Find the two numbers that's in between, take the square root of them, and then decide it's a little bit closer to 49 than it is to 64, so then it's going to be a little bit closer to 7 than it is to 8, and 7.5. Remember, 7.4. 7.5 would be right smack dab in the middle. Okay, that's it, and I'll see you guys tomorrow.